Hey guys, welcome back. In this module, we are going to discuss about an important device called optocoupler or opto isolator also. So let's begin. So first of all, what is an optocoupler and how does it look? So when you talk about how does it look, it looks like this. These are the optocouplers, and where are they fitted? They will be fitted in the input and output modules. And what are they doing? They are providing safety to the PLC. What kind of safety? Let's see. So if you zoom in here, let's study. So this is the PLC here.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respectship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mother.
It's a PLC. And this is the input module to the PLC. Input module. And now in this input module, we have got multiple inputs here. So channel 1, 2, 3, like that. And then there's a common channel. So let's first of all wire this up. We'll provide a battery connected, negative connected to the common, fine, and then positive connected to switches. Let's say there's one switch here, on off switch. That would be a pressure switch. So what happens is then it is going to carry the current like this. And then there is a small load, as I told you, that of course in a circuit you have to have a load, otherwise there'll be, it's like a short circuit situation, current will go high. So this is the load that is preventing short circuit in the situation, and it will maintain the current value in the system. So now after that it goes to this this LED basically, and post that this goes towards the sink. So it goes and then sync back to the same source or the battery where it all started. So the loop is complete, LED is glowing, and then LED is glowing onto a photocell. This is the photocell here. So photocell received a signals that yes, LED is glowing. So internal circuit will be energized and it will sense that there is a 1 or on. So this channel number 1 will be sensed as on, and that's what all PLC needs to know. PLC does not need to know what is the current value in this line, voltage value in this line, any problem in this line. It only needs to know if this hand switch is triggered or not triggered. And it has come to know even though there is no touching between the two circuits. And that's what matters. There is no physical contact. It's all galvanically isolated. But why do we do that? So the thing is, if let's say there is a direct connection with an electrical wire, what are the problems? Problem is, if let's say there is an earth fault in this line, somewhere there is an earth fault, grounding, then the PLCs, this is somehow, if there's an electrical connection, PLC is also getting impacted because of this earth fault, right? And this can create sparks or something like that, some problems in the PLC itself. So the first problem we are solving will be protection against short to earth faults, right? If let's say there is one more line also gone earth. So let's say this is number 1 only. Let's say this line also goes earth. Here, this also goes earth. Then these two are joined together, right? Right, or let's say not from here, but let's say some internal component also earth. So these two are shorting now. Right? So we don't want to have the problem of earthing reaching to the PLC side. Secondly, if there is any electrical noise in the circuit, or let's say transient spike, surge, or electrical noise, interference and all. We don't want that to communicate to the PLC side. It is going to damage the PLC components. We know that. So if there is something, some spike, at least this is going to get damaged, that at least PLC will be saved. PLC is more costlier here. All right. Then suppose you want to resolve this by having the let's say relay inside and magnetically linked together. And that is also a solution to avoid these two problems. A relay, because it is not a relay coil, you just energize a coil. There is a coil inside and then there is a contact here. That could also be the solution. There is also no touching here, isn't it? But it will bring another problem. It will solve one problem, but it will bring another problem. Means chit chat, means at least some physical motion is happening here, right? So the contacts will wear out fast, right? So you want some permanent solution to this problem. And that permanent solution is you make this arrangement, and this arrangement now combined in one assembly, and this assembly is called optocoupler. So this coupling is optical, means using light, and it is happening all inside this. So I hope we all understood now what is the optocouplers used in the PLC. So that's all for now. I'll see you in the next video.